Hi, my name is Azza E Ahmed, and I'm a PhD student at the University of Khartoum in Sudan and Groningen in the Netherlands. This work is a comparative analysis of workflow management systems in production genomics research and lecturing. As we know, biology today is a data-intensive science with a lot of focus on computation. And routine analysis actually are highly complex, necessitating modular workflow design and also efficient expression of those workflows programmatically. In this work, we performed a systematic evaluation of some of the popular bioinformatics workflow management systems and some of their executors. These are Nextflow, CWL, and Meter, and we compare them against Swift, a workflow management system that is commonly used in high-scale physics applications. We do this via two case studies. In the first, we build a variant coding pipeline in each language to assess their expressiveness. And in the second, we select executors of those languages to assess their scalability. Language-wise, and while we do observe that the core systems follow the flow paradigm, yet they do vary in their features. Swifty, for a starter, has the familiar C-like syntax and feel, so it has great ability to express complex logic and advanced algorithms as well. Nextflow, on the other hand, is Groovy-based, so it has the object-oriented look and feel of Java, along with access to any of its libraries. So it's similarly powerful for expressing patterns, though easier to work with than Swifty. CWL and Weedle, on the other hand, are a lot more involved to write and very restrictive in their expressiveness. For Weedle, there are no custom functions and a limited library of basic operations. CWL, on the other hand, also has no functions, but JavaScript blocks could be used to express complex patterns if needed. Unlike the others, conditionals were not officially introduced in CWL until version 1.2 of the specification that is now being proposed. Of course, these aspects are a bit limiting for experienced programmers, though they do indeed enforce good coding and clearer coding practices. Conveniently, graphical user interfaces exist for these languages. For example, here we see the pipeline builder for Weedle code and the Ventine extension from the Radix team for CWL code. Additionally, executors for those languages or systems provide means to learning the dependency graph of a given workflow. Here we see it for Weedle and CWL on dry run, whereas for Nextflow, we see it learned from the provenance records. Actually, these DAGs are for our scalability study, where we have a hostname command that is scattered as an array of n parallel processes across n code, and we do have a chain of two such hostname commands. In each figure and in each language, we see the unique feature of any language. For example, for Nextflow, we see the unique channels and their operators, while for CWL and Weedle, we see the scattered patterns readily visible in those figures. As for engines, we can say about Nextflow and Swifty that they are complete, in that both the language and engine features co-evolve together. However, CWL and Weedle are only language specifications, and thus different engines exist for each of them. And these engines, of course, vary in their specification version and the features they do support. In our scalability testing, we opted for Cromwell, as we could run it locally on an HPC environment and the cloud. Other engines either could not run with both languages in all of these environments, or were a bit more involved to set up videos, or is no longer supported by its core developer team. And now let's talk about scalability. Here we deployed our DAGs from the previous figures into an AWS fixed Slurm-based parallel cluster of 9600 cores. This allowed us to evaluate the overhead on task management from the total workload on time, as our hostname command visually consumes no resources. Also, this allowed us to evaluate the quality of node packaging. Actually, let's start with the later. Here, our expectation is the ideal situations where no node is being overused. We see Cromwell, which is the black lines or dots here, closely following the theoretical expectations. While with Nextflow, here we see patterns of overqueuing or overusing nodes. This could be due to the way we were controlling for parallelization. With Cromwell, we were controlling its job rate control parameter, whereas for Nextflow, we were only controlling the max force directive while leaving the queue size at the default value of 100. Actually, those overqueuing patterns happen at over 100 tasks, which is to be expected in this case. However, Nextflow was still up to 4 times faster than Cromwell, as we could see from the bigger figure above. Generally, though, at lower task counts, both of them were scaling linearly with increasing the number of tasks, while at higher counts and 1,000 and beyond, both of them were failing, with Cromwell distinctly taking longer time to clean up and exist. While we do only show patterns for Cromwell with Weedle, the same pattern was observed for Cromwell when run with CWL. Reflecting broadly, we could say about Cromwell, Nextflow, and CWL that all of them were produced by practicing by informaticians, which meant close alignment with the needs of communities like dynamic scheduling, portability, robustness, and accessibility. Of course, these aspects also matter in the clinic, with additional focus on validation and conformance to regulations. Actually, the wide adoption of those systems is possible due to permissive open source licenses being used, like Apache 2.0 and BSD3. This is also a nice case where industry is both a player and shareholder in developing workflows. The open sharing practices and shared principles are also a player in this adoption. Critically, though, the rapid evolution of those standards and languages would necessitate frameworks for evaluating conformance of engines and languages. We will continue to see in the future innovations at the levels of infrastructure and big data analysis in the development of workflow management systems as well. Finally, and for more about these evaluations, find our blogs here or get in touch via email or Twitter. And last but not least, we are left with thanking and acknowledging our funders and support teams. And also, thank you for your attention.